Today I'll show you how a two-way switch works. You'll learn the basic working principles step by step, then we'll wire a complete circuit from scratch, and I'll show you practical tips, wire color coding across different countries, and how the same principle applies no matter the wiring system or equipment you're using. First, let's clear up the terminology. In Britain, this thing, where you can control the light from two different places, is called a two-way switch. In North America, the same thing is called a three-way switch. In Britain or in British English, the switches are named after number of locations you can control the light from. In America, the switches are named after number of terminals you have on the switch. So in order for that thing to work, you need a switch with 3 terminals, so 3 wires connected to the switch. In this video, I'll use the term two-way switch simply because I'm used to it. Now let's see how it works. We'll take power from our circuit breaker here. The neutral goes directly to the light. The light goes to the switch. And then back to the light. I've already explained this basic switch circuit in the previous video, you can watch that one too if you want. Now look at this switch. It has 3 terminals. One common terminal for the live input, usually marked L, and 2 switch terminals that the common connects to one at a time. Here I've connected the wire going to the light to one of the switch terminals. Power on. In this position the light is off because the common connects to the other terminal with no wire on it. In this position the light is on because the common connects to the terminal that feeds the light. Now let's add a second switch down the line, but connect the 2 switches together with only one wire. To do that, I'll move the wire that goes to the light onto the second switch, off, and I'll use a single wire to link the 2 switches together. This lets us test whether one wire between the switches is enough to control the light from both locations. As soon as we turn the first switch off, the second switch does nothing. The light stops here at the first switch. Obviously that's not very useful. To fix this, we add a second wire between the 2 switches. These 2 wires are called the travelers. This is the common, and these are the travelers. They create 2 possible paths for the light to travel between the switches. If you flip either switch, it changes the path. Now the path is closed, so the circuit is complete. When the path is broken, the light turns off. When the path is complete again, the light turns on again. So to summarize this simply, bring the neutral directly to the light. Bring the live line to the first switch and connect it to the common terminal. Run 2 wires as travelers and connect them to the traveler terminals. From the common terminal on the second switch, run the wire to the light. So that's the basic working principle. Now let's put this into a more realistic scenario. In real installations, the cables won't be routed the same way we did on the table. Depending on the layout of the room, the location of the switches and the light, and local electrical regulations, there are many different ways to run wires for a two-way switch. The principle will always be the same, but how you physically run the wires will be different. I'll show you one way that is very common, where everything is wired through a junction box. Let's say we have a single floor house and we want to install a two-way switch in this hallway. One switch by the entrance door, another one by the living room door, light is on the ceiling in the center of a hallway, and our fuse board is in the utility room. We would place a junction box up in the attic, in between all these elements, and run all the cables to it. It looks complicated at first, but if you followed along and now you understand the principle, it's actually quite simple. So we have a fuse board where we will take power from 2 switches, a light, and a junction box where all the wires come into. First I'll run all the conduits to the junction box, from the fuse board, the switches, and the light. we bring our mains, live, neutral and ground, from the fuse board into the junction box. Yes, we have a ground wire as well for all exposed metal parts on your light fixtures or even switches. If a light fixture or a switch has a ground terminal, you must run a ground wire to it. The ground doesn't carry current during normal operation. It's a safety backup that only comes into play when something goes wrong. Here in France, most of the switches have full plastic enclosure, so you don't need to run a ground wire to them. However, here is required to run a ground to every light, regardless of what fitting you're planning to install. For your specific country, you check the regulations. Now, from the junction box to the light, I'll run 3 wires again, live, neutral and ground. This time I'll use brown as a live, and I'll explain you later why. Okay, now I'll explain why I'm using these colors. In Europe, including the UK, the neutral is always blue, the ground is always green-yellow, and for the live you can use any other color than blue or green-yellow. It's usually brown or black, but you can use other colors too. In France, red is often used as a live, as a direct live, so the one that's always live. And other colors like black, brown, orange are used in between the switches from switch to the light and so on. In the US, the neutral is white and the live is black. And sometimes other colors like brown are used in between the switches from switch to the light and so on. The ground is green or green-yellow or just a bare conductor, and you will put a piece of green-yellow insulation on it only inside the box. Anyway, here we stick to the French colors and we'll also match the colors that we used on the table. The neutral and the ground go directly to the light, so we'll connect them right away and focus on the live and the switching. Now we run wires to the switches. Each switch has 3 terminals, 1 common and 2 travelers, so we need 3 wires per switch. For this switch here, I'll use red as a common and 2 orange wires as travelers. For this switch here, I'll use 2 orange wires as travelers and brown as a common. Now the traveler wires only pass through the junction box. 1 traveler from the first switch connects to 1 traveler from the second switch. And the same thing for the second traveler. That creates the link between the 2 switches. It doesn't matter which traveler from the first switch you connect to which traveler from the second switch. You just don't connect these 2 together because obviously that's not going to work. Then we take the live, hot, from the supply and connect it to the common of the first switch. Then we connect the common from the second switch to the live that goes to the light. So what we did inside the junction box, we have only spliced the wires, each one is only passing through the box. Now the only thing that is left is to install our switches, our light, and to connect everything to the fuse board. These are the switches that we are going to install. 3 terminals, L for common, 1 and 2 for the travelers. These are the automatic terminals. We strip 12 mm of insulation and just step the wire in. The common that goes to the light, 1 traveler, doesn't matter which one, and the second one. We'll pop the covers even if they don't do anything here. This is the light fit that we are going to install. It's called a dispositif de connexion luminaire. French thing, as you might have guessed. You install this first and then you install your light fitting to it later. It's like a socket, but for lights. So we have 3 terminals, neutral, ground, and the live. Oh yeah, again, 12 millimeters of insulation. So now I can finally close this box. Now the only thing that is left is to connect our mains to the fuse board. The ground wire goes to the ground terminal. That will be the same in every country. It's not very powerful. Now in France the neutral connects to the circuit breaker, but in most of the other countries you would have a bus bar where all the neutrals go to. So yeah, both neutral and the live, they are connected to the circuit breaker. As you can see, the principle is the same as before, only the physical routing of the wires is different. Now we only have to turn our breaker on and to test it. This is just one of many possible ways to run wires for a two-way switch. Depending on the layout of the room, the distance between these elements and their location, there are several other layouts. More often than not, this would be part of a larger wiring system, so you wouldn't be running a separate cable directly from the fuse board for only one light. And obviously the materials will be different from country to country, between different types of construction. Here I've run individual wires in conduit, but you could use cables with multiple conductors in a cable, and so on. Now when you know the working principle, maybe you can think yourself of different ways to run wires for a two-way switch. I'll make a dedicated video on this subject later, but please let me know in the comments what you came up with. I hope you've enjoyed this video and found it useful, and see you in the next one.